Well, this is another video for Math3430. We're going to continue our study of object-oriented programming. Last time I talked about the code over here on the left and how I create a class and a subclass. So a class is a specification of a kind of object, like the class of all apples, and it specifies an apple. So this was going to used to create objects of a certain type, my class. Okay, when you create one, this init method gets called. This is a double underscore and a double underscore. Count the number of underscores. It's not so easy to see on the screen if you've got 2 or 3. Okay, and self refers to the object that's being created, the object of this class. So this method gets called with the object we're creating and some external data x and y. We store them in the object as attributes of the object, self.x, self.y. That tells it to look in self. And then I have a print all method. You apply it to self, and it just prints self.x and self.y. Here's move, which could cause them self.x and self.y to change. So it's not a totally pointless class that just stores x and y. Okay, and then I create a subclass, something that inherits from my class. And the way you tell it to inherit is like this. Put the name of the parent class in parentheses after the name of the subclass. Okay, we need to define an init method for it. This is going to have x, y, and z. So first we want to initialize the data in the parent class. So this subclass is going to have x, y, and z. An object of the parent class only has x and y. So just for pedagogical purposes, we can say you could get the parent class definition by super, and then I call the init method of the parent class, and I leave out the self parameter because that is supplied when you do this. When you call one of these methods, it automatically supplies the first parameter, so you don't specify it when you call the method on an object. Okay, and then we set self.z to z. Okay, now I'm going to define a method print all of self. So it just has self, which will be automatically supplied. So it's only going to have open parentheses to call it. And I print x, y, and z. Now you'll notice I have the same method name as in the upper class, in the parent class. So what happens? Well, the one in the subclass overrides the one in the superclass. So it should call this method on a type of object of type subclass. So the idea is that a subclass extends, adds more information to a superclass, and so it got a smaller collection of objects than there is from the superclass, and it should respond to it responds automatically to all the superclass methods. So you could do move on an object of type subclass. It would be fairly pointless since it only does x and y, but we could override that one too. And so it can do anything the superclass can do, and then it can add its own methods, and it can override methods of the superclass. That's what they mean by polymorphism. Okay, so this prints x, y, and z, and here I just demonstrated that you could define this function by calling the print all method in the superclass, which we're overriding here, you can call that method the method in the superclass. and add to it the new Z information. Just printing, it doesn't seem worth doing that, but you can. And then for demonstration purposes, I've defined a class of miscellaneous, which it doesn't inherit from anything, so it has nothing to do with my class or with the subclass. So here's the init method. I'm storing x and y again, only I'm going to print them out horizontally. Okay, so let's exercise some of this in practice. So here's a call of this statement creates an object of my class and calls it MC1, my class 1. And x and y are 2. So to create an object of a given class, you call the class name, and then you give it the parameters, put parameters in here. Those parameters get passed to the init method. So I made 3 of those, and then I did this objects of the subclass, which are in the multiplied by 10, so you can distinguish them, and a miscellaneous object where it's in hundreds. Okay, here's a list that has miscellaneous object, my class object 1, subclass 1, my class 2, subclass 2, my class 3. Okay, so let's run this. So if I look at L, I get that junk because it's a list of objects, and this thing doesn't know how to print objects. This says it's an object of type main at my class at this address, which we don't worry about for our purposes. And this thing with the double underscore scores is the name of the module. The top of your code at executing the interpreter is the main module, and this module would be called whatever I called the file, which is obj1. Okay, now what do I do? Well, let's do for object. I don't want to use O x in L x dot print me. So in this case we have objects of both the parent class and the subclass. My class object has no I didn't know that. Oh, print all. Sorry. Getting ahead of myself. Print all. Okay, so 1, 2 come from object of my class, 10, 20, 30 come from the object of type subclass, and so on. So they both have a print me method, print all method, and you call the print all method on one, you get it works. So that's called polymorphism, that subclasses can change the behavior of the superclass, but it looks the same to the code. I didn't say, I didn't have to distinguish here which was in the superclass or the subclass. So that's the point of that. And then L2, I added a class of miscellaneous object, and miscellaneous has a print all method. And if you tried this in a strictly typed language like C++, it wouldn't like this list, because it should all be things that are one class or its subclass, and it would object when you put that one in. But Python doesn't care what the type of list objects is, and it doesn't, it kind of takes the wind out of the polymorphism stuff by having something looser called duck typing, which is based on a phrase like, if it swims like a duck and it quacks like a duck, then it's a duck. So it'll take anything that has the right methods defined. In this case, it'll take objects of type miss because it has a print all method. It doesn't care. It's a different object tree. So you could call, that's a rather looser standard. It makes it dependent on the programmer to know that you're calling the right thing, that when you create an object this type and pass it to a routine that calls a method on it, it better have that method. So for x in L2, x.print all. Okay, so it used these classes the way they're supposed to be, and since MM had a print all method, it called it, and you printed the horizontal 100 and 200. Okay, so this duck typing thing is widely used in Python. A good example is the iterator protocol. You can iterate over an object provided it has 3 methods, and they're called the right thing. Just the method name. It doesn't matter what happens inside the object, what kind of object it is. Okay, of course it has to be able to do something after that. Okay, so that's a review of this code. I have a larger, somewhat more realistic, not realistic, but somewhat more realistic project. Here I can show you. Okay, so here it is. First of all, I'm going to make an address book that holds contact information. And the contact information is going to be a name and an email address. So the first thing to look at is the class contact, which holds the contact information. Okay, let this pass for now. I'll come back. So I'm going to define a class that has data name and email, and it has one more piece of data, which is ID num. So I'm going to assign a unique ID num to each class, to each contact. So the point of that is I'll always be sure of finding a given contact if I can find its ID number. Finding it by other methods is not so certain. You might say I can find it by name. Well, we'll have a search by name, but names in real life are very complex things. Okay, and then it has a print me method, so its contacts are in charge of printing themselves. It prints the ID number, the name, and the email. So right here I initialize the ID num by saying global last ID num. Okay, so the last ID is kept in this variable last ID num, which is a module level variable. The module we're in is the file, and the name of the module is the name of the file, obj. So if necessary, I could import obj1. So in Python, modules just means code that's in one file, and the name of the module is the name of the file. Okay, so having contacts, I'm going to create the address book. Okay, so this is class address book, and the initializer just creates an empty list. So self.list LST gets set to empty list. Okay, and then to add a new contact, you have to write a method self, it's going to get replaced by the object, and the contact, that's an object of type contact, and we do self.list append contact. Of course, the fact that it's of class contact is used later. Right now, this method would be happy to put anything in the list, which is a problem, perhaps. Okay, and then I added a little procedure to step through a list of contacts and add them all to the array because I didn't want to type separate list creation lines. Okay, and I'm doing implementation hiding here. Ideally, you should be able to change the implementation, like changing from an array to a dictionary inside the class without affecting what derived classes do or anybody else's code outside. If you change a method name, people who put this in their big programs won't be able to call it. It'll crash. But so I just use new contact here. So if I changed methods, I would have to change this new contact function, but I wouldn't have to change this one. Okay, and just for debugging purposes, I've got a method called _peek, which takes no parameters when you call it, and it just returns the whole list. That's just for debugging purposes. And the underscore in front of the peek is Python convention again. In strict object-oriented languages have, private classes have private variables and public variables and friendly variables and so on. In Python, there's no way to protect anything like that. They're all public. They can, anybody who's got an object of your class can fool with them. But if the underscore tells the programmer who's doing that this is a private method, it involves the implementation, he probably shouldn't fool with it. Think thrice before you override a private method or change a private variable. Okay, then we're going to print contacts. So I make it alphabetized by name. And we talked before about in the sorted function, you can give a function that returns a key from the record, from the object. In this case, it's the name. So it sorts by name. And here's this procedure for printing a list of contacts. I sort of thought it should go with the contacts because it prints a list of contacts, just deals with contacts. But it doesn't deal with a particular object really, so it's a class method. It's the same procedure to all members, no matter what you implement. It's referring to one piece of code. And here's how you call it, by putting the name of the class first. So the contact class, contact tells me I'm calling print contact from the class contact. You'll notice from this call that it gets past the name of it gets past the class, so it can change things in the class. And but I'm not doing that here. Again, you should be very cautious about doing something like that. Okay, so this depends on the implementation, but it's a user method. They're going to use it, client programmer. so I don't really want to make it private. And then find contact by name. I'm going to search for contacts whose name field has name as a subscript, a substring. I'm getting tongue-tied. I guess I don't know, I must be pretty annoying to listen to because I get tongue-tied all the time. But anyway, so the contacts that finds are stuffed on the list, found list, and we return found list, which is going to be a list of contact type objects. The reason for that is, of course, since I'm just doing substring matching, more than one object might have that as a substring, so you want to look at them and see which one is the one you want. Okay, and then I have this one, which really should be private. It's index, find the index in the array by the ID num. So take an ID num, return the index in the array. So ID is the ID num you're looking for. So you just search for it element by element until you find one, and then you return that index. I don't have to find a list of them because ID numbers are supposed to be unique. So there's only one. There's at most one of them. And if there's none of them, this return statement will not get executed, and this return statement will be executed and return none to indicate a failed search. Okay, find contact by ID number. Just uses this function and returns the list element at that index. So the contact you're looking for by ID number. And then delete contact by ID number is the same thing. If you match it, you find it by calling this function up here to get the index. If you get none, then it wasn't found, so you return none for a failed deletion attempt. If it's not is found, then this is how you delete a list element. The list, the element to index to delete, and the delete keyword. So that will delete things from the list. Okay, so that's good. And you can exercise that code a little. I have here C1, C2, C3 are create objects of type contact. Again, that's how you create an object in a class. You call the name of the class and the parameters that go to the init procedure of that class. So C1, C2, and C3. So let's just stick with those for the moment. So there, it printed all of itself. So so if you do C1.printMe, it prints itself. It says ID number 1, and the name is Santa. This is a little holiday flavor here, and so on. So let's see, if we search for the names up here, you'll notice that I have the first one alphabetically is Frosty, but there's also a Frosty Jr. So if I search for Frosty, I'm going to get both of those. So I created an address book named AB. So let's do AB address book, find contact by name, and let's say the string is Frosty. And let's call that C, since it's an object of type contact. What's wrong here? Okay. And what I get, of course, is a list of things that match that string. So if I do for C in L, I mean L is a list of objects, contact objects. There's two of them. So if you do for C in L, C.printMe, okay, so we get Frosty and Frosty Jr. How are we going to get exactly Frosty without getting Frosty Jr.? Well, we got the ID number, so we can do it by the ID number. So we can say find address book, find by ID number, find contact ID num, I think I called it, and the ID number for Frosty is 2, and of course I have to print it. It's going to be one contact, so I can just say dot print me. Okay, so now we got Frosty and his email address. Okay, well, you might say, well, that's all very good, well and good. I can look up email addresses. I, of course, don't intend the final user to use these commands. You would write some sort of a interface to it, either use the module in Python for writing command line interfaces, or use the module, or use a GUI toolkit if you want a windowing system. So how do you okay, so that's for regular people. You have all their email addresses. You might decide, if they're friends of yours, do you want their phone number? Okay, so how would you go about that? Well, let's subclass contact and make it a structure that stores 3 pieces of data: name, email, and phone number, called phone. And we first call the superclass initializer to initialize name and email, and then we store away self.phone in the object we're creating. And we modify printMe so that it prints the phone number. As the previous example showed, I could easily call the super printMe method to print name and email, but it didn't, just for a print statement didn't seem worthwhile. Okay, so this is a subclass of class contact, and it responds to the same methods, in this case only printMe and an overridden version in friendly contact, responds to the same methods as the upper superclass. In this case, it doesn't define any more of its own, but that it could. So basically, you could plug one of these friendly contact classes in any place you could put a contact. So I create C0 as a friendly contact, Tinkerbell, And this is Tinkerbell's phone number. I hope 999, that's a made-up phone number, of course. I hope 999 is not a real area code. And then Rudolph is a friendly contact, and Tux is the penguin that represents Linux, and he's at the South Pole. That's where penguins live, not at the North Pole. Good to know. Okay, so this address book should be able to store objects of type friendly contact, and you know it does. A address book print contacts ab.print contacts. So that's calling the procedure in the superclass, but that calls the print me procedure on each object, which is polymorphic. It's different in the subclass than in the superclass, but that doesn't matter. It'll call the print me method on the object you're talking about. So if you do AB print contacts, you get this. So Santa was not a friend. You don't call Santa up and talk to him about how nice you were. So it's putting these in alphabetical order by name. Okay, and it prints the ID number. So then you could, of course, delete it if you wanted it to, or look it up by ID number. So AB find contact by, I didn't say by, ID num is, let's say 0. And of course it's a contact object, so it doesn't print anything except for the address it's at. It's a friendly contact. So let me copy this down here. So let's just set it equal to a variable, not necessary as we saw, but let's set it equal to a variable. So that variable has type friendly contact, right? Yeah, friendly contact. And then that is a friendly contact, but it has a print all procedure, print me procedure. And it prints the contact you wanted. So this is pretty crude, of course. I mean, developing a real application like that wouldn't fit in one video. So that's about what I had to say about object-oriented programming. This is just an introduction to the subject. There's lots of tricks you can pull, and especially in Python with duck typing. So if you're going to try and write an object-oriented program of any size, then read a book. But this will serve for our class purposes, so you know what an object is. And you should be able to use a few simple classes. Okay, that's my lecture on this, so I will sign out now.